Welcome to the fourth and last part of our introduction. It refers to testing benches or dynos. Testing benches or dynos are mandatory to test a shock absorber and to understand if it works properly or not. And if it doesn't work properly, to understand which is the problem and which could be the solution. Depending on the application or depending on which kind of shock absorber we are working with, there is a proper testing bench. Let me do some examples. One testing bench is working with an engine that is using a timing belt to move a flywheel. The flywheel moves a bearing into this kind of mechanism and it moves up and down the shock absorber. This is a system that is very nice, very precise, and very quiet. And its dimensions are also very small. So is the best solution when you need a small testing bench. So is the best solution for motorbikes and shock absorbers for Formula, because are soft and small shock absorbers. And it is a small and light testing bench, so the best solution if you have to install it on a truck or to send it by airplane. Suppose that you need something stronger, maybe because your shock absorber is for cars or trucks or hard applications. In this case, it is suggested to work with different solutions, like could be a rod, because even if more noisy, with more vibrations, it is much more resistant. And this is important if you are working with hard shock absorber generating 500, 600, 700 kilos, and you need to test hundreds of thousands of these shock absorbers. Just to make other example of testing benches, there are testing benches also for forks. In this case, the dimensions are bigger, and in many cases, the shock absorber is moved through an hydraulic system. These are the best testing benches at all, but of course they are much more expensive than any other testing bench. Then there are many other types of testing benches. In some cases, you can test 6 shock absorbers or more at the same time. They are fine when you have to make tests of endurance and to see what happened to a shock absorber when working after months and months and months. In our case, we have to make mainly quality control. Quality control of production or remanufacturing. So we are looking to performance testing benches. And we are looking to a very resistant testing bench that could last many years. So our suggestion is to choose a testing bench with a flywheel and one rod. Okay? In this case, we have an engine that is moving the flywheel. And depending on the position of the rod, we will have the shock absorber compressed or extended. Suppose that we are here, the lower point, that we will call it A. In this case, and suppose that our flywheel is moving always at the same speed. Suppose that is moving always at 0.13 meters per second. When we will be here, the flywheel will be moving at 0.13 meters per second, but the shock absorber, the speed of the shock absorber will be 0. And once we overcome position A, the speed of the shock absorber will increase, and will be increased during all B. And when arriving here, the C point, the shock absorber will achieve its maximum speed, that will be 0.13 meters per second. Then the speed of the shock absorber will decrease within return to 0. Then the shock absorber will be extended and its speed will increase again within arriving to 0.13 meters per second and will decrease again to 0. At this point, the speed of the flywheel will increase to 0.26 meters per second, and also the speed of the shock absorber will increase from 0 to 0.26 to 0 to 0.26 and rebound, etc. On the top of the testing bench, we have a cell load that is checking the force of the shock absorber in rebound and in compression. So we will have diagrams like this. Here we have the force in rebound in kilos, the force in compression in kilos, and here the displacement of the shock absorber. Here is the dot A, so the shock absorber is completely extended, and at the beginning will be accelerated passing through B to C, within achieving the maximum speed of 0.13 meters per second. And in this position, we will have the maximum force in rebound, in compression. So the force in compression will increase from 0 to the maximum value. Then it will decrease within arriving to E at 0. And then the shock absorber will be pulled, increasing its speed and force within F, and then here achieving its maximum speed and force in rebound. And again will return to 0. Then, as I said before, we will have a new diagram at higher speed and with higher forces, that is the pink case. And the speed will be higher and the force will be higher too. And so on. Many speeds and many different forces. In this case, we have the diagram force versus displacement. And it's very useful to understand how the speed changed from 0 to the maximum speed of each cycle. The problem, the limit in this diagram is that we don't know the speed here. We know the speed here, 0, here, 0, and here, that is the maximum speed of each cycle, but not here. So, but we see how the diagram is changing. Now, the dyno has a software able to transform this diagram, force versus displacement, in force versus speed. Very simple. Here we have the force in rebound, the force in compression, and the displacement. We know that the first diagram, that during the first diagram we achieved the maximum speed of 0.065 meters per second, and these were the maximum forces. During the second cycle, we achieved the maximum speed here of 0.13 meters per second, and we achieved these forces, and so on. In this way, we have the two diagrams that we need to judge a shock absorber. Force versus displacement and force versus speed. Both are mandatory to understand if the shock absorber works properly or not. Why? Because if we compare these two diagrams of two shock absorbers for the same application, we can understand if the two shock absorbers works in the same way or if one is softer or harder than the other, and if the difference is sensible or not. So we can understand if the right shock absorber and the left shock absorber works in the same way, and if they are working as they should work based on the right test that we did. With this diagram, we see if each single shock absorber works properly, independently from the fact that the force is right or not. So we understand if the oil is moving properly into the valve. How do we understand if the oil is moving properly into the valve or not? Very simple. We have to judge how much symmetric is the diagram. If it is symmetric, the oil is moving properly. If it is not symmetric, there is something strange that can be accepted or not depending on the shock absorber. And we understand if it doesn't depend on the speed, just on the valves. Using these two different diagrams, we understand if the shock absorber works as it must do or not. Thank you.